see. I have the poll up. All right, we have some people logging in. Excellent. Wait just a couple seconds, couple minutes right here while we let people log in. As you're logging in, please feel free to answer the questions on the poll. I'm going to do a quick introduction in just a minute. Looks like we have some people logging in. We're going to do some introductions here in just 1 second. Make sure you take a couple seconds to answer the poll. We only have three questions on here, so help us out and answer the poll while you're getting set up in the webinar. Okay, I'm going to go ahead and get us started. Welcome everyone to Webinar Wednesday. We're excited to have you all here again. We are recording this session, so if you have questions you want to revisit, it will be available on our website. We do have a poll going, so if you just logged in, make sure you go ahead and answer the questions on the poll. We'll go ahead and share those results in a second. But I just want to do a little bit of housekeeping real quick. We will take questions during the program, but we're going to reserve the answering the questions till the end. So down at the bottom of your screen, you should be able to see the Q&A speech bubbles. As you have questions during the program, go ahead and ask your questions there, and I'll read them out loud to the group at the end. And Taz and Travis will answer those questions for you. If you have questions that are directly related to logistics of the Zoom program or something directly for me, I'm the facilitator for the webinar today, you can reach me directly through the chat, and I can answer your questions directly through there. I want to welcome you all again for joining us today. Please make sure you go ahead and answer the poll. I'm going to share the results in just 1 second. But today we have Broan speaking to us today about the solutions for providing best living environment for homes. And Taz and Travis are going to go ahead and present to us today. I'm going to let them introduce themselves, and then we'll go ahead and share the results from the poll. Go ahead, Taz and Travis.
Perfect. Thank you, Emma. I appreciate it. My name is Taz. I'm the product manager at Broan for our Overture product.
Hello, everybody. My name is Travis Rash. I'm our senior product manager for our fresh air systems category. Along in the call is also John Hayes, who's our director of sales for the fresh air system segment.
And today we'll be talking to you about a number of different fresh air and automation solutions for indoor air quality, both from a builder perspective and a homeowner perspective. We'll kind of go through the why, the what's, and the types of products that we offer and how they can help you improve indoor air quality within the homes that you guys are building today. So to kick us kind of off, we'll start off with just a couple of questions. The main question that we get kind of at a high level is, why do we need to ventilate? And when we talk about indoor air quality here at Broan, we always reference a number of different things, but primarily one of the things that we always reference is the studies that are done by the EPA. We talk about how we're spending more time now than ever inside the home as opposed to out. Every single day we take 25,000 breaths. 90% of those are typically taken within an inside environment. And as a direct result of that, indoor air quality can actually be about 5 times worse than outdoor air quality. You might be thinking, well, what are some of the things that can contribute to that poor indoor air quality? What am I doing that can make indoor air quality worse? And it's really just about daily life, whether you're cooking, you're cleaning, you're dusting, you're bringing furniture in, or you're taking a shower. All of our daily lives contribute to worse indoor air quality. And to solve that, we really need to ventilate. We need to have products that bring fresh air in and bring fresh air, or bring poor exhausted air out of that space. And so one of the main things that we've seen over the past couple of years is this trend of homeowners asking or wanting good indoor air quality from builders. You could take a look. There's a number of different studies that we're citing here, but a main one that we're looking at is kind of one that was done by Green Builder Media back in 2015. And what they did is they asked a number of different builders and a number of different homeowners, would they be willing to pay more for indoor air quality products? And an astounding 86% of them at this time said they would. And this was actually done in 2015. You can imagine what that looks like now with the pandemic, the 2020, the 2021s, and how that might have even shifted to a much larger number. And one of the main things that we also get is from a builder perspective, why should I focus on indoor air quality? Isn't it something that the homeowner should focus on once they come into the space? And there's two kind of problems with that. The first one on the left is that homeowners typically don't know when indoor air quality is bad. Whether it's pollutants like CO2 and VOCs, some of them can't be sensed at all by just our basic senses. And then what we're seeing here on the left is also another study done by the EPA where they put a number of individuals in a room and tested their comfort level as they induced more and more particulates into that space. And they started feeling negatively around the 150 mark, when in reality, action or ventilation was really needed around the 40 mark. And so you'll see there's a large discrepancy there between what we can sense and when we actually need better indoor air quality. And so from a homeowner perspective, a homeowner may not know that their indoor air quality is bad at all for the 10, 15, 30 years that they're living in that space. And then on the flip side, on the right-hand side there, retrofittable ventilation solutions are typically hard to implement once the home is put together. If you're thinking about changing from a microwave to something like a range hood for your indoor air quality, that's a very hard ask for someone that has a home to already put in and duct properly. Same thing with things like fresh air systems. If you're going to add a retrofittable ERV, HRV, these products are typically a little bit more difficult to install once the home is put together. So the process really should lie on the builders, and during the building process to focus on indoor air quality then, so that we could get it done right, we can get it done easily.
So as Taz mentioned, important to get ventilation, and there are three main solutions when it comes to ventilation. We have our exhaust, so we have our exhaust fans, we have our kitchen range hoods. Again, as Taz mentioned, getting those pollutants out of the home initially, again, whether it's humidity in your bathroom or you're cooking with oils, again, letting that kitchen range hood do that work, getting that bad polluted air out of the home. We have supply solution. So this is where we are introducing fresh air into the dwelling or into the home's air handling system. Again, a constant supply of fresh air. Fresh air dilution is very important when it comes to providing overall indoor air quality. And then we have balanced ventilation. So that's where we're talking about our HRVs, our ERVs. We're providing a neutral pressurization of the home. Again, we have a controlled source of fresh air, and we are also extracting stale air out of the home at the same time. Provide a little bit more detail on that balanced ventilation. So you'll hear the term HRV, or heat recovery ventilator, or ERV, energy recovery ventilator. It's at that time that we are taking, as the diagrams show, that we're taking, whether it's that fresh, hot, humid air in an ERV case, we're utilizing that stale air, item number 2, from the building. So we typically condition that air to a cooler temperature, remove some of that humidity through our air handling system. It's at that time we're able to take that stale air, make it do some work, and ultimately temper the air, or item number 4, that's being delivered to the dwelling itself. So opposite could be said during heating season, winter time, we got that cool, dry air coming into the house. Again, we're typically heating our homes to a certain temperature. We're able to pre-temper that air prior to that air entering the home's air handling system or the dwelling itself by going through a heat exchanger or energy recovery ventilator. Another benefit we have with balanced ventilation, if you can imagine that fresh air that's coming into the home, really that first line of defense is that filtration that's in the ERV. There are a number of different levels of different filtration levels. As Taz mentioned, as you go up in higher filtration, you can see the different particle matters. You can see the different things that MERV or that filter can capture. And so the higher we go in the MERV rating, as an example, the more things we're able to capture through that filter. Again, having that filter be that first line of defense before that fresh air even hits your home's air handling system. So with that, I'll pass it back over to Taz and talk more about indoor air quality monitoring.
Thanks, Travis. And so when we talk about our homes and how kind of we're building them today, one of the main things that we see is this trend towards energy efficiency. What we're looking at here is a graph showing ACH 50, or practically a home's tightness level over a period of time. And so you could see from the very left-hand side, back in 1975, we were building homes that were relatively not airtight. So ventilation was not a problem as it was today, because your home would naturally ventilate through the cracks and crevices throughout the entire structure of your home. Over those years, we've gotten progressively better at insulating and providing a tighter home for our individuals due to energy concerns. And nowadays we're seeing standards of 2 to 3 ACH, and even getting down as low to 0.5 with certain technologies. When we look at the problems that that can cause due to indoor air quality, you've now basically put a balloon or a bubble around the house. And so what stays in the home is not just your energy, your heated and tempered air, but also all the air quality pollutants that you're using, the particulate matters, the VOCs, et cetera. And so when we look at the certain pollutants that are generated within a home, you can break them down into four relatively large ones. The first one on the top left-hand corner is CO2. CO2 is a byproduct of what we breathe. We breathe in oxygen and breathe out CO2. One of the things that we're seeing in a lot of newer homes is an influx of CO2, especially in certain rooms during certain times of the day. Think bedrooms, think living rooms, areas where people will congregate. Another problem, and Travis will touch on this again in later part of the presentation, is a large amount of humidity. Individuals, unfortunately, are not doing things like turning on their bath fans when they shower, and homes are being built so tight that they're trapping a lot of the humidity from individuals living in the space, from cooking, from cleaning, mopping, whatever it may be. And so there's kind of this optimum zone of humidity. You don't want to be too dry where you're going to induce a lot of viruses, bacteria, and other respiratory infections, but you also don't want to be too humid, inducing things like mold, mildew, and mites. And so ensuring that you're in that optimum zone is super important to reduce some of the issues that can happen. From a bottom left-hand side corner, one of the other things that we're seeing are these things called volatile organic compounds, otherwise known as VOCs. These are gases and chemicals that are in the air that are produced by not just things that you do, whether it's cooking, cleaning, you can think of these kind of like odors, but they're also produced by just the furniture in your home. If you have a dog or a cat, they also produce a certain amount of VOCs. People also produce VOCs. If you've ever walked into a home and there's kind of a weird smell or kind of a funk to it, typically that's a result of a high level of VOCs. And then in the bottom right corner, when you look at particulate matter, we're talking particulate matter that is very, very small. You'll see there a comparison of a human hair being about 50 to 70 microns in width, where what we're talking about is particulate matter that is very small, around the 2.5 microns in width. And the importance of that is once you get down to that level of particulate matter, the individuals and humans that are breathing that air in have a really hard time getting that out of their system and just coughing it out. It actually can get into your bloodstream and cause a number of different health issues. Typically, you'll see this from cooking, from fireplaces, from just dusting and natural day activities. But again, all of these can be built up in excess due to the way that we're building our homes today. And so one of the things we always get is, it's great that you guys have done the work to kind of identify some of these, but what does this mean to me and my health? And I'll tell you, there's a number of different studies and research, some done by the American Lung Association, some done by the EPA, and others done by different state or local universities that really provide us with a good idea of the immediate and long-term effects. And the news is that it's not very good. When you look at indoor air quality pollution over a period of a couple of minutes versus a couple of years, both are very bad for you from both a cognitive function as well as a long-term health perspective. And so all of these indoor air quality pollutants can come in many different forms. Some of them we can't really see, some of them we can't really sense, but they're there, and the way that we're building our homes are making that much worse than before. And one other thing to talk about is when we talk about ventilation for a specific home, typically the way that we do that is we have a calculation that we use that allows us to provide a certain level of CFM or volume of air, either to exhaust or supply within the home. And we need to start thinking a little bit more proactively. You could take a good example here with one home in the middle and two different families that may potentially live in that home. And their different indoor air quality needs are much more different when you look at it side by side. From an occupancy perspective, the family on the left is only 2 people, and the family on the right is 6 people, and they have a dog. So right off the bat, you're going to have a lot more CO2 in that space. And then looking at more activity-based pollution, whether they're working from home, eating versus cooking, whether they're cleaning with natural products or with harsh chemicals, the length and average time of their shower all contributes to different levels of pollutants within that space. And you can see how 2 different families may have completely different ventilation needs, and not only when they first move into the house, but also when they progress throughout their life. They may have a kid that goes to college. They may introduce more family members. They may get additional pets. And so what we really need is a way to kind of tailor fit ventilation based on the individuals living in that space. And that's what we've kind of developed here. We looked at a number of different products that we've had in the past. We've been developing air quality products for over 90 years now. And whether it's the bath fan, the range hood, or some of our fresh air system products, we wanted a way to automate all of these products based on indoor air quality. You can think kind of like a thermostat automates your furnace or your air conditioner, depending on the temperature. Overture automates your indoor air quality based on the pollutants and the amount of indoor air quality problems that you have within the space. So the three main products are the wall control. If we go to the kind of next slide here, the wall control, which measures indoor air quality. It measures for VOCs, humidity, CO2, and temperature. And that controls things like your bath fan, your range hood. It has a dual gang switch for a light and a fan, and then can actually communicate with the other products within the system. So if you look at the middle product there, that's our room sensor. It plugs into any 120 volt outlet within your home. And that also measures temperature, humidity, VOCs, CO2, and particulate matter. You'll typically place this in a place without ventilation. So think like your bedroom, your living room, your home office, and it can communicate with either a range hood, bath fan, or a fresh air system, depending on what you have connected, and actually call for indoor air quality or ventilation when those pollutants reach unhealthy levels. On the very right-hand side, we've also got our smart plug. Our smart plug is meant to control a number of our fresh air system products, whether it's an ERV, an HRV, a supply fan, or even a makeup air damper. We've got low voltage connectors that connect to all these products and actually boost them to provide additional ventilation when needed, when one of the sensors picks up an indoor air quality issue. All of it is connected via an app. There's a simple app where you could set everything up within 5 minutes. It's a free download. You get to see a year of historical data. We're actually seeing some customers use this product for indoor air quality diagnostics. So even after the fact that a home's built, they may have some issues or may be running into some problems, and they're using the product that way. It does monitor every single room, so it's scalable. You can go as high or as low as you'd like to. And then we do measure air quality every 5 seconds. So every 5 seconds, we're taking a sample for all of the pollutants that we talked about earlier, making sure that they're in check. And if at any point any one of these products detects an indoor air quality issue, we will ventilate according to how you have the system set up. And then we also do have some third-party applications. So things like Alexa and Google Home, where you could actually use your voice to learn a little bit more about indoor air quality, trigger your bath fan, your lights, whatever it is that you want to do.
So with that, we'll jump into dehumidification. As Taz has mentioned, dehumidification plays a key role in overall indoor air quality management. So humidity management being that, as Taz had shown before, there's kind of an optimal range between that 30% and that 60% relative humidity range. As you can see, what kind of happens, as Taz mentioned, as you get drier air, those particle matters that he talked about earlier typically stay suspended in that air longer. For those in the north, it's not a coincidence that during near that winter time, we often get very sick. Most of us around us get sick. If you can think about it, if that dry air is there, that particle matter, all those things that Taz had mentioned earlier are floating in that air, ultimately enter our respiratory system, and what do you know, we get sick. Vice versa could be said when we come to those very moist conditions. So if I'm in the hot, humid south, again, that air is very heavy. There's a lot of humidity in that air. Those particle matters that we talked about earlier drop out of the air very quickly, ultimately attach themselves to surfaces. And next thing you know, you have mold and mildew growth growing on different areas like your grout, anything that can stay moist for a extended period of time. So comes the mold and mildew mitigation. Again, as Taz mentioned, our homes are becoming tighter and tighter. Again, we've done a great job of sealing up the envelope. Again, we as human beings are producing moisture. Some of the materials that we have inside our homes are producing moisture. Us obviously showering, cooking are all things that are contributing to the overall moisture inside of our homes. Ultimately, we need to mitigate that. Again, reduce the chances of any kind of mold or mildew growing. Again, those obviously have health impacts as well as the overall integrity of your home itself. And then we also have shoulder season. So that time of the year, we're coming out of it. You got that springtime, you got that fall time area, those months where the outdoor temperature may not be hot enough or cold enough to really have our AC system or heating system run. So we don't have any heating or cooling calls happening. So we're not getting any of our typical ventilation going on with our air handling system. There's no air movement really going on. But during these times of the year, still the humidity is still very high. So it's at this time that because we can't rely on our air conditioner to kind of reduce the overall humidity in the home, that whole home dehumidifier really comes into helping bridge that time of that year. So a really high reliance on that whole home dehumidifier, picking up the humidity management during those times of the year. So we talk about relative humidity. We talked about some of those percentages. Let's take a look at what starts happening at these different relative humidity percentages. So 85%, very, very hot and humid. It's at this time you start to really get those wood floors, the trim you may have start to rot, start to blister, paint. Again, we're having so much humidity that we're starting to literally have these overall products basically come apart at this time. 75%. So this is where you're going to start seeing the cupping of those wood floors, stains of the walls and ceilings. Again, you can really start to see signs that your relative humidity is staying sustained at a very high percentage. And again, you're starting to have really the breakdown of certain building materials happening at this time. 60%. So if we sustain relative humidity percentage above 60%, that's where we're going to see the mold and mildew growth continue. And that's where it's really going to proliferate. Again, if we can break that cycle is when we can, again, mitigate and ultimately control that. That 50% range is really where we're feeling our overall health is there, our comfort. We're maintaining the overall structure of our property itself. So that's really that sweet spot when we look at that relative humidity percentage and ultimately contributing to better indoor health and quality of life. So what is the goal of dehumidification? So if we look at what ASHRAE has deemed as the ideal design comfort. So as you can see here, when we come to ASHRAE calculations, we look at what the temperature is. We're given a range. So Taz may feel more comfortable at 80.5 degrees. I may feel more comfortable at 75 degrees. But at the end of the day, based on all the work ASHRAE has done, they have determined that the 50% relative humidity is the key number. So even though he may be more comfortable at higher temperature, I may be more comfortable at a lower temperature. We're going to feel that most when it's at 50% relative humidity. So a good example of this, particularly in those hot, humid south climates where you may not have supplemental dehumidification, you'll have that homeowner start really trying to crank down their thermostat. So they'll try to take it from maybe a comfortable 74 degrees, try to crank that down to 64, thinking it's going to overcome the clamminess or the uncomfortable environment that they have. What they're really trying to compensate for is that 50% relative humidity number. So again, they're trying to adjust the temperature to really deal with what is actually a humidity condition. And then the other part is to protect the customer's property. So again, I talked about it earlier, breaking that 60% relative humidity cycle. So again, without the use of air conditioning, how are we going to maintain that environment, that dwelling, crawl space, whatever it might be, under that 60% relative humidity threshold? By doing so, again, we're going to be able to mitigate the chances of any kind of mold and mildew growth happening. So I haven't had a dehumidifier. What's changing? We talked about it earlier. To improve the overall energy efficiency, Taz showed it earlier on the overall tightness of the homes dropping significantly since those 1975 timeframe. So again, to improve energy efficiency, we built our homes tighter and tighter. The techniques we're using, maybe the HERS scores or the EPA or the Indoor Air Quality Plus, those metrics that we're trying to hit to get, whether it's incentives or just honestly provide an overall more energy efficient home, has again developed that tighter and tighter envelope. And so with these more efficient homes, we're able to reduce the size of our air handling systems. So again, maybe we're going away from a 3-ton, maybe we can get away with a 2-ton, because again, we've done a great job of making that overall building envelope tighter. So our need for taking care of cooling loads or heating loads has dropped. So again, we're able to have small equipment. What that means is we have less AC runtime. So again, if we're in those hot, humid climates, when our AC runtime is reduced because of our more efficient homes, we're getting less of that typical dehumidification we used to get with those larger systems and those longer runtimes. Smaller equipment, less runtime means we're getting less dehumidification from our air conditioning systems. So again, this is where that supplemental dehumidification really comes in key to being added to that overall humidity control within the home. With these new systems, these A coils are getting much larger. They're holding more water. What that means is, again, we're keeping moisture inside the system. As that system comes back up to speed, there's more water sitting in these coils. So we're going to basically start rehumidifying the air as that air passes across it. We know this new equipment with the SEER ratings that we're chasing, there's more sensible happening. We're chasing more sensible loads than we are really dealing with latent loads. So again, this new equipment isn't necessarily dealing with the latent loads that they used to, because we're going after more sensible type efficiency requirements. Spray foam is a fantastic product of basically creating an overall sealed environment, but also, so we've done a great job of sealing the outside from infiltrating inside. But spray foam was also doing a fantastic job of creating that bubble that Taz referred to earlier. We're keeping all that moisture inside that envelope, again, by a product like spray foam. So what are some of the things that we look for when it comes to needing dehumidification? So first, an obvious one, again, physically, what we can see, the mold, the mildew growth, whether it's around the grout lines in your shower, or maybe it's, I've seen extreme examples where a electrical outlet placed on the exterior wall had a perfect mold ring around where the cutout was. So there's enough temperature difference in condensation to occur that there was actual mold growing around the perfect rectangle that was the electrical box in that area. Discoloration around registers. So again, if we're moving that cold air across that register and we hit a certain dew point, we can get condensation to occur around those registers. There's some great examples you'll see where you may even have like metal registers start to rust, again, because we've had such a temperature difference that we have that condensation point occurring around those registers. Talked about it earlier, go into a house, you have that homeowner, again, cranking down that thermostat, trying to get their home cool enough so they're more comfortable. But again, what they're really trying to overcome is a humidity related issue. It's not the fact that it's a temperature thing. So as we had discussed earlier, we're comfortable at different temperatures, but really what it comes down to is controlling our relative humidity. And then again, you may have condensation around windows, around supply registers. Again, as those differences in temperature occur, whether it's us, again, trying to really reduce the overall temperature inside our home, but again, the outside might be very hot and humid. You get that condensation around those windows, those supply registers. So with all that said, when it comes to Broan's overall product portfolio, we have 4 key SKUs when it comes to dehumidification. We have our B33 DHW unit. This is an in-wall dehumidifier that has a 33 pint per day capacity. So this physically can mount inside a 2x6 wall cavity as is. It can mount inside a 2x4 wall cavity, whether you let the back of the product protrude through the other side of the wall. Otherwise, we have different basically mounting kits or bezel kits to again space that out. This is a very unique product. It really lends itself well to those multifamily dwellings where maybe you don't have that mechanical room or your mechanical room is so small, but you still need that dehumidification. Very well positioned for those coastal areas or anywhere along the hot, humid south area where again, you're trying to overall control that humidity inside of a smaller house or a dwelling. So again, square footage coverage up to 1,200 square feet, knowing that it's really a cubic measurement we're looking at. All the values we're providing here in square footage is actually factored into 10-foot ceilings. So again, we're very conservative when we talk about our square footage coverage. But again, that B33 DHW in-wall dehumidifier, again, very self-sufficient. All the controls, the drain, the wiring is all contained within the unit itself. So there's no exterior items that you have to install with the product. Again, a very unique offering in the market. Then we jump into our ducted dehumidifiers. We have our B70 DHV. So this is a 70 pint per day capacity dehumidifier. Does very well for those smaller dwellings, basement humidity control. All of our ducted dehumidifiers come with MERV 13 filtration standard. So again, as we saw earlier in this presentation, what MERV 13 does for us, Again, if we're introducing maybe fresh air into the home, having it pass through that MERV 13 filter first, or if we're recycling the air inside the home, again, having it pass through that MERV 13 filter provides an additional layer of filtration for this. 1,800 square feet of coverage. So again, cubic measurement, again, based on 10-foot ceiling heights. Again, it's nice. It's a nice, small, compact unit. It does have a built-on humidity sensor and dial. So if you are in those basement type situations where you don't want to necessarily have to mount a separate humidistat or a thermostat with humidity sensing, you have the ability to set that on the product itself. Jump up to our B98 DHV. So again, 98 pints per day capacity, same MERV 13 filtration we had talked about previously. This is where we introduced the use of an outdoor air fresher inlet. So you can see in that bottom left image, you have that smaller 6-inch duct. It has a mechanical damper on it, so you can throttle the airflow coming from the fresh air in from the outside as you need. Again, you have that 2,300 square feet of coverage, so larger dehumidification capability, larger blower fans. Again, this product and the B120 we'll talk to next really fall in that sweet spot when it comes to that overall whole home dehumidification. We have our B120 DHV. So again, this is kind of the bigger brother to that 98, physically a little bit larger, a little bit larger dehumidification components, blower fan, again, to get us that higher pints per day capacity. Same MERV 13 filtration. You have access to the MERV 13 on both sides of the product. So depending on where the product is mounted, maybe you only have one side access to it. Again, you're able to pull out that pleated MERV 13 filter, replace it as necessary. Again, with this product, you're able to bring that fresh air in from the outside. And again, utilize the ventilation components of this dehumidifier. Again, with the higher pints per day capacity, the larger unit, we're also able to cover more square footage within the home itself. So that's kind of a high level overview of both our indoor air quality products as well as our dehumidification line from Broan. So with that, we'll go ahead and jump into questions. It looks like there's a few in the chat as well as the question and answers area. So
Excellent. Excellent, both of you. Thank you so much. We do have a question from Scott. He is curious about the connectivity of the sensors that you spoke about. Are they Wi-Fi, Bluetooth, power line connectivity? What kind of technology obsolescence guarantee is there? And do you offer help for the less tech savvy individuals, or do you leave it to the web?
Yeah, absolutely. We've got a number of different ways that we can help you, whether that's our direct line, reaching out to our product managers, myself, and our customer support team. But more importantly, we actually have a customer or a construction sales manager that's directly in your area that can help you set up either your first time, your second time, whatever it is, if you want to set up the product. From a connectivity perspective, all of this works off of standard 2.4 gigahertz Wi-Fi. So every single home today has Wi-Fi built into it. Every single home has 2.4 gigahertz Wi-Fi. We do use Bluetooth for onboarding, so you do need to be near the product when you're actually onboarding it. But to actually access the data and reach to it, you could really be anywhere. You could be in a coffee shop, you could be at home, you could be really anywhere you're at. So very standard communication protocols that we use. And then from a support perspective, again, we have a number of different materials, our customer support line, as well as your construction sales manager in the area, and then myself as well.
maybe we want to talk a little bit with the handoff between whether it's an integrator or builder.
Yeah, absolutely. So a lot of our builders are using I'll say a number of different trades to install the product, whether it's your electrician, your HVAC contractor, or even your integrator, if you have one of those. All three of those have expressed pretty much how easy the product is to set up. So if you've got 5 minutes on your hand and you have a Wi-Fi connection within the home, you're more than welcome to try and get a sample and set it up yourself. It should not take more than 5 minutes. The process is very simple. You set up a home and then rooms, and then you put the actual devices in those rooms. The communication, of course, again, is based off Wi-Fi. So no real issues there. And again, depending on who your contractor is and who you want to actually put the product is, it was made in a way that it's not overly complex or overly hard for any of your trades to actually put it in.
So from an app standpoint, if the Jones have the new house, the contractor sets up the Overture piece, assuming they have the Overture app, they can do the handoff and
Absolutely.
give that to the Jones.
So there's a way that you could actually transfer home ownership or co-own a specific home. So if your HVAC contractor is interested in monitoring that air quality, even after the devices are set up, they can actually share that home with the homeowner. So both the homeowner and the actual trade has the information that they need and the historical data that they can see for monitoring over a period of time. And then additionally, if the HVAC contractor or whoever it is that's putting the product in no longer wants to see that information, they could also do something called a transfer, where they give that information over to the homeowner completely. And then on their end, they're the only owners, they're the only ones that can see that. So very smooth and easy transition from trade to homeowner to builder, even if you're interested. We've had a lot of different builders express some interest in wanting to see their air quality, wanting to monitor the homes that they've built and take, maybe slightly corrective action, or maybe put in different products and see how the humidity levels are, or how the kitchen air quality is when they put in a rain hood. Lots of cool stuff. And especially with the historical data, it allows you to kind of visualize the air quality like never before.
Wow, that's amazing. We have two more questions. Mark put in his question first, so we'll go with his. Can the sensors be adapted to other manufacturers' ERVs?
Yeah, so there's a compatibility list that we have with our products that we can guarantee all of our products work with. If you are using a competitor's product, you certainly can. I would just do a little bit of research. There are some ERVs that have, they don't use 24-volt dry contacts, they actually use 120. So just be careful with that. If you're curious if one of the products work with our smart plug, reach out again, either to myself or our construction sales manager. We can do a little bit of research and let you know relatively quickly if you have one in mind.
Excellent. So basically that's a yes, but double check.
Yeah, it's a yes, but just be sure what you're doing. That's all.
Excellent. Our other question is from Rick. He wants to know, does the Overture system interface with the Broan AI series of ERVs?
Yeah, so you can actually set up an awesome air quality solution by using both the AI series and Overture. So the way that you would do that, obviously you would get all the benefits of the AI series, both monitoring outdoor information, the automatic balancing of that product, super easy, simple setup, the simplest on the actual market. And then on the Overture side, if you plug a smart plug to it, to the override ports of that, and then have a room sensor anywhere within your home, you can actually have a very awesome indoor air quality solution that both allows you to monitor outdoor incoming temperatures, allow you to self-balance, and then on top of it, monitoring indoor air quality wherever you put that room sensor, and then boosting that ERV to its maximum CFM whenever there's an indoor air quality event. So you get both kind of the best of energy efficiency and simple setup and air quality, all kind of in, I'll say, 3 simple products.
So Taz, my AI series, let's say it's running continuously at 70 CFM, whether it's an ASHRAE number I'm trying to meet or just providing overall indoor air quality. What you're saying is that room sensor that we showed earlier senses one of those particulate matters or VOC, whatever it might be. It'll send a signal to the smart plug, which through the low voltage will basically tell the AI series to boost to whatever that high speed is. It'll do that until that event, part of whatever that indoor air quality event goes away. And then the AI series will resume whatever that operation was before.
That's absolutely correct. A lot of our ERVs and HRVs are actually much more capable than what they're set to right out of the box. Whether it's 50, whether it's 60 or 70 CFM that you have it running continuously, you can actually provide, I'll say, anywhere between 110 and 130 CFM into that space if you put it into boost mode. And that's exactly what Overture does. So it allows you to continuously run at low CFMs to meet your energy efficiency ratings, to provide continuous ventilation. And then when there is air quality events, let's say you're cooking, let's say you're cleaning, let's say you just took a shower, whatever it may be, you can actually have that ERV go to its maximum CFM, provide the highest level of air quality at the quickest rate, and then boost back down to its intended continuous rate.
Excellent. It doesn't look like we have any more questions. If we do. There's always one more when I say that. Do you have an updated HRV, ERV compliant with new building codes in California that went into effect on April 1st?
We do, and we'll actually be announcing. So all of the Broan AI series products, the 18 SKUs, will be California fault indicator display or FID compliant. as well as their four main wall controls that go along with that compliance. So with the FID compliance, you need to notify the homeowner via visual indicator. In our case, our wall controls, we have a little LED light, or in our touch screen, an icon that flashes with the screen lit up. That'll notify the homeowner or the contractor that something has faulted within the system. And ultimately, it'll tell the error code on the AI series product with the LCD screen that's there, what that error code is. With the AI series, we also have that LCD screen on board today. It displays your airflow, as well as there has been a software update. Products that were built many, many months ago in production already have that software update that'll display the other required for information for your FID compliance. So that includes like the watt usage, as well as your real-time airflow rate. So again, you'll be able to design in during that design process, knowing that any of the Broan AI series products, HRV, ERV, any of the 18 SKUs are compliant, along with any of the wall controls that are on there. Is listed now on the CEC website as of May 19th, I believe. So we are out there now. We are CEC certified, and you'll see more information coming from us in the very near future regards to that FID compliance.
Excellent. Thank you so much. If there's, I'll leave it open for just another little minute. It looks like if I'm going to repost the poll real quick for those that are just, only this first 6 people that logged in were able to see the poll, it looks like. So I'm going to go ahead and relaunch it while we see if there's anybody else who has questions. But I want to thank you guys very much for joining us today. It's great information. I love to hear that you're innovative and all the great things that you're offering to our builders. And thank you again for your partnership with Builder Partnerships. We have enjoyed our partnership with you for all these years. So thank you everybody for joining us today. We look forward to having you again in 2 weeks for our next webinar Wednesday. It doesn't look like there's any other questions. So with that, I'll say thank you very much, and you all have a great day.
Thank you. I appreciate the time.
Thank you. Looks like we have one more person. Excellent.
Thank you, Emma.